I will continue. So relationship, we have said two entities are there. Both of them have a relationship. We link them together through a link. And foreign keys in ERD diagrams, where in SQL, we link them through foreign key constraint only. We can have relationship between two entities or maybe more than two entities as well. Now we will look at the example which is given here. It is also from the view-ridge diagram. We are saying that we have a customer which may generate many transactions. So which means we have a customer entity. I'm not creating the entire figure for you. I'm just mentioning the name of the entity here, the transaction. And we are saying that one customer will generate many transactions, which means one customer, he have visit one restaurant and he have placed an order, maybe a burger. Once he have placed an order for the burger, he ate it, he feel like that he want to buy another, maybe another drink, maybe another burger. So he will go back to the cashier, pay for the second burger or maybe a drink. So it will generate a second transaction for him. So first one, when he bought the first burger, first invoice. Once he want another drink, maybe, or maybe another burger, he went back to the cashier, pay for it, he will get another invoice. So which means one customer can generate one transaction or one customer can generate multiple transactions as well. Now for each transaction is generated by one employee only. So we are saying one employee, one transaction will be generated by one customer. So this is what this explanation is about. But I want you to consider whenever we have a customer and transaction, how we can draw a relationship between them. How you should identify, is it one-to-one or one-to-many? So you will focus now on that. Now this part, this is how the scenario have given to you, but how you can identify whether you can, how you can write one relation only instead of reading it. Okay, because in reading we have to read both directional, but when we write it, we just write one-to-many or one-to-one, how we can write it. So this is a step we follow for that. So we are saying we have a customer and we have a transaction here. So I will remove this part here from here. Again, I will write for you the customer and transaction. So we are saying that one customer, I'm writing it here, the first step, one customer will generate one transaction because he bought first time the burger only maybe. And then we are saying that the same customer, which is one customer, he will go back to the cashier, pay for the second burger or maybe for another drink. So it becomes many transactions. So whenever we have 2 transactions, 3 transactions, 4 transactions, it means it is many. Okay. This is for left to right. Now from right to left. From the right to left, we are saying that one transaction is belong to one customer. Now, is it possible that one transaction is belong to many customers? What do you think? Is it possible? Any one of you? Is it possible that one transaction or one invoice is belong to many customers? No. Yes, Tristan, you are right. It is not possible. So which means now we have to find a final output for that. So you can see here, if you remember, whenever we have 1, 1, 1, which means it should be 1 here. If you have n here, it should be n. So I'm looking at 1 and 1 and 1, which means it will be many here. This is our final answer here. So we'll place 1 here and many on the transaction side. Is it clear? This is one way of identifying how you can finalize the last relationship between two entities, whether it's one-to-one or one-to-many. We have read it into 2 directions, but in 4 steps. Is it clear? Anyone who want me to repeat it? If you don't want me to repeat it, I will not repeat it. But if you want me to repeat, I will do that. Is it clear? Can anyone say yes or no at least? Okay. Okay, it's fine then. So I will move ahead. So your final answer will be 1M. Remember this way, this is 4 steps, bidirectional, left to right 2 steps, right to left 2 steps, and the final answer when you look at the minimum and maximum. Okay, so I have canceled the M here, but I asked myself that whether that many should be possible. I said not possible because we are saying that one invoice should be belong to one customer. It cannot be multi-customer who is buying using the same transaction. Okay, he will not have the same invoice. So that's why it is canceled. It is not possible. Now let's move to the next slide. So how we can identify the occurrence of each of the instances, or we call it as an occurrence diagram, or how we can identify how many relationships are there. We use or we draw an occurrence diagram for that. It may be useful for you. We call this diagram as a semantic net diagram as well, or instant diagram. So if you remember, I have said that whenever I will use instance can be used for the entity, it can be used for record, it can be used for attributes as well. But in this specific scenario, you will find that they are calling the instance as a record, as a row, as an each value we have in the row. So now let's look at here in the diagram, we have staff and branch, which are 2 entities are here, and both of them have a relationship between each other. In branch, we have 2 branches, which is B003, B007. And we have in staff, we have 3 staff are here, SG37, SG14, and SA9. Now, in order to identify that how many relationships will be there, whether it's one-to-one, one-to-many, or many-to-many, what we are trying to do it here, we are trying to link each instance in a branch with each instance which is given in a staff. We have considered here a branch number and staff number, which is a primary key or a unique key. Okay. So now let's look at the first one. B003, which is branch 003, have 1 employee, which is SG37, and the same branch have another employee who is working there, SG14, which means we have 2 employees who are working in branch B003. So as it's 2, which means it's many. Now let's look at the second one, which is B007. This branch only have 1 employee or 1 staff who works there, which is SA9. So we have only 1, which means we have 1 relationship here. So if you want to read a relationship between both of them, you can see here that 1 employee can work in only 1 branches. Now let's read from the staff to the branch. So SG37 is belong to only 1 branch, SG14 is belong to only 1 branch, which is B003, SA9 is also belong to 1 branch. So which means 1 staff should belong to only 1 branch, and 1 branch can have multiple staff. So what will be the answer will be here? 1-many. How you can identify here? You can see here each branch is belong to only 1 staff, or it is belong to multiple staff, but 1 staff should be belong to 1 branch only. Okay, I will explain more in detail about the cardinality here. One thing more you have to consider here, which is related to something called as, in case if you're opening a new branch here, which is B006. So we have opened a new branch and we haven't hired any employee yet. No employee has been hired or assigned to that branch. In that case, in this scenario, we do not have any instance here in the star, which means our relationship becomes zero, which means we have something called as a mandatory and optional. We use for the mandatory a vertical line, and for the optional, we call it as zero, circle, or O for the optional, as you want to, whatever you want to call it. Okay, these are different conventions I use. We call it as a cardinality or participation. I will explain again these concepts to you. But in this specific scenario, we do not have any relationship with the star, which means we have optional relationship between branch and staff. If we do not have, in a scenario, we do not have a new branch where we have to assign an employee or hire an employee, we will consider it as a must, which means each branch we have it here should have one staff, which is given in the scenario before scenario, okay, without having a new branch. Any questions? We do not call it as a zero to many, we call it as one to many, but zero will be here. If you have seen in your diagram, we have something like this. Okay, we have something like these. So these are the ones which identify whether it's optional or is it mandatory. We do not call it as zero to many. We will still call it a one to many, but still we will just identify the cardinality here. I will explain in a while the cardinalities to you. Okay, is it clear? Anyone who want me to repeat it? I will be repeating the participation again. So this is for you to understand it. I will move to the next diagram or next slide, which is about the cardinality. I have said that cardinality means it will be optional or mandatory. We categorize cardinality into minimum cardinality and maximum cardinality, because minimum cardinality and maximum cardinality help us to identify whether our scenario is optional or relationship is optional or mandatory. We have 4 types of symbols are here. You can see here we have zero and many, the crowfoot, which means this is a cardinality here. And this part is connectivity. The cardinality is always on our left side, and the right side is our connectivity. I'm talking about the one of entity 2 relationship. So now here the cardinality, zero means it is optional. Again, I'm repeating that. And vertical line of 1, it means it is mandatory. So the first one can be read as optional and mandatory. The second one, mandatory and many. Then we have 2 vertical line, which means it is 1, which is mandatory and 1 relationship. And the fourth one here is optional and 1. Again, I will repeat. The first one is optional and many. The second one is mandatory and many. The third one is mandatory and 1. Then the fourth one here is optional and 1. So these are some of the type of symbols we will be using in our ERD diagrams. Any questions here? So now what is minimum cardinality? So minimum cardinality means we have to look at the number of minimum occurrences of instances in an entity. We call it as optionality, ordinality, or participation. We always categorize the cardinalities, either it's minimum or maximum, as an optional or the mandatory. We use a keyword for optional and the mandatory are these ones. So whenever we have optional, we always look at something called as may or may not have or not. Whenever we have mandatory, Mandatory means we are referring to must or should have, or we can also say that mandatory, it will be at least. So it will be certain keywords which are used to give you a hint that whether should we say it is an optional or is a mandatory. Okay, these are some of the keywords we have to look at in the scenario. Now, what is minimum cardinality? Same diagram which I have I have shown to you earlier, and have it in one new branch here. So you can see here, we said we have 0 relationship, we have 1 relationship, and we have a many relationship. So we in minimum cardinality, which means we will look at which one is minimum here. So minimum here is 0, which means it is optional. Now we have something called as a maximum cardinality. So we will look at the maximum of it. So maximum here, we are again considering all the relationship here. Whatever the maximum here, M means it will be mandatory. Even if it's at least 1, still it means it is mandatory. What does it mean? For example, when we are saying that it's not necessary for one branch to have a staff. Only in the scenario when we have a new branch and we haven't assigned any employee yet to that branch. In that case, we can say that, okay, it is optional. But we do not, when we do not have any new branch, and we say that one branch at least should have, or should have 1 employee or more than 1 employee, then it becomes mandatory. Because in most of the cases, you will find that one branch must have a staff, but only in exceptional case when we are saying that there is a new branch which we have opened, and then we have to assign an employee to them. Means currently we haven't assigned or we haven't hired any employee for the specific branch. In that case, it can become an optional. So you always have to look at the scenario or assumptions you are making whenever you are selecting mandatory or optional. Okay, is it clear now? Is it clear? Anyone who want me to repeat? Okay, so I will move ahead. No one have asked me any questions. So it's the same explanation which I have given to you. So you can look at it. Okay, so in case if you want to look back onto the same explanation which I have given to you, but it's written in the written format. Okay, so now we have something called as connectivity. So I have already mentioned the cardinalities are the ones which is on the corner ones, and the one which is on that side are the connectivities. So what are the connectivities? We call them as a classification as well. The one-to-one, one-to-many, or many-to-many. These are all connectivity, which is attached to mainly an entity itself. So I will remove these ones so it will be more clear for you. So you can see here the one which is attached to entity itself. It is a classification or connectivity. We call them as a connectivity. It is one-to-one, one-to-many, or one-to-n as well. You can find both conventions in majority of the books. Okay, so both of them are acceptable. Or you also find something like this as well. It is also acceptable, but I will suggest you to use these ones. Then you have something called as many-to-many. These are some of the ways you can see that some of the books have it present them. All of them are acceptable. You can also find something like this as well. Okay. But I will suggest you, in case if you're writing, you can write in that manner. But in ERD, we use it as these symbols. Okay, these are connectivity, and then we add our cardinalities, whether it's optional or is it mandatory. Okay, hope it makes sense now. So before I explain one-to-one relationship, I will go back to my lab so I can finalize that one. So I can show you how you can add a connectivity to your diagram. Hopefully you can see the visual file now. Then I will move back to one-to-one and one-to-many relationships. So let's say this is two entities are here. You can call it as trans again. I haven't completed this table for you. It was just an example. I just want to show you how you can drag and drop the entity or relationships. So you can drag and drop here. You can fix it by connecting on the dots, which is given here. So you can see here it has a point. So whenever you tamper with the points, it will let you fix the points as well. So for example, it has points. You can just drag and drop here and it will straighten up for you. Okay. If one doesn't work, you can look at the second one. Okay. So now how we can change a symbols here. You can see here right now it is optional and many. So how you can change it, you will right click on it. First click on the link, right click, you can see here it is set begin symbol and set end symbol. We said that we have mandatory and optional. So in these set symbols or set begin symbols or end symbols, you can see here we have something start with 0, 1, 1, and 0. So the left side is all about the cardinalities and the right side is about connectivity. In the same way, you can see that in the end symbol as well. 0, 1, 1, 0, these are cardinalities, optional and mandatory. And the left and the right side, which is more, 1 and 1, these are your connectivity. So let's try to change it in case if you want to. You can see the set begin symbol says 0 more. Always look at which part is begin and which is end, because sometimes when you drag and drop, by default, it will give you this side as a start and this side as an end. So you can try to figure out which one is end, which is a start. You always look at it. Okay. So by default, it give you set as a many and optional and mandatory and 1. So in case if you want to, let's say I want to set it as 1 or more, or maybe as 0 or more. It is not correct. I'm just trying to show you how to change it. Okay, this is how you can change in visual files. One thing which I want to highlight here for the visual itself or diagram which we are drawing, we said that it should look like something like this. Hopefully you can see my diagram. So there is one mistake in the book which I have noticed, because this is the exact same diagram which we have drawn. So if you're talking about the relationship between the customer and transaction, both of them it says optional. But there is a mistake here. What is the mistake? Because it's not clearly given that what exactly the scenario is about. So when we are saying the customer and transaction, okay, so let's say customer and transaction here. We are saying that one customer should have many transactions. Right? But one customer must have one transaction or optional. What do you think? What do you think should be must or optional? Whenever we are considering the must and optional, we always read on the left side, right, from left to right. So for example, if you're reading customer to transaction, we always put the optional mandatory on the right side. But we read from left to right, the way I have drawn for you the arrow. I have given you one slide in your PowerPoint or handout lecture notes, which I have given to you. You can find that slide as well. How do you add must and optional? You always read from left to right, but you add the symbol on the right side. You read from the left to right, but you add on the right side. So now you can see here it says optional. It's true, because not all customer will buy any product from you or generate any transaction, but they will be still a customer. Okay, so optional is correct here. But when we read from transaction to the customer, we are saying that it's optional. Is it possible that one transaction is not belong to, it's not required to be belong to a customer? Is it possible? Is it possible that transaction to customer, it's optional, which means one invoice which has been generated, it cannot be belong to any of the customer. So it says in the diagram it's optional, but I believe that it should be belong to someone. Yes, Tristan, you are right. It should be belong to someone. So technically it should be mandatory here. Okay, but as per book, it says optional. So we will keep the diagram as it is. In the lab 3, you do not have to change it. Keep it as it is because we are imitating the same diagram. But technically, you should know how to differentiate, how to understand the what is wrong and what is right, because some of the books have mistakes. Okay, and we have to make sure that we understand them correctly. I will try my best to identify them. And I think so whom I think the semester 3 students also have mentioned that the other lecturers whom they have taught, they also mentioned the same thing, that there are mistakes in the book, but I will try my best to identify the ones which is there. Okay, so hopefully you understand what mistake is here, but you do not have to fix for the lab 3. You will fix anything you want to in your exercise 4, week 4 exercises. Whatever you are doing in the ERD, whatever you are whatever diagram you're creating for your phase 1, you have to make sure you are providing justification as well. Justification is your assumptions, that why do you think it's mandatory or optional? Because sometimes you're thinking in different scenarios and I will not understand that. I want to understand how you have drawn it, how you have given us 1 to 1, then I will be able to give you marks. Okay, so that's why I will suggest you, whenever you draw your ERD diagrams, give me assumptions, because there is no right and wrong answer, but you have to make sure that it's logically correct. Okay. Now, already have explained this part. You will complete your lab 3 and submit it after that, because there is nothing left. And now we'll go back to your lecture. So now we have first relationship, which is 1-to-1. But do you have any questions? Do you have any questions? Anyone of you? Okay, so I will continue with it. So here we have, okay. So here we have 1-to-1 relationship. I have given you all scenarios here. Okay. I have given you mandatory to mandatory, mandatory to optional. I have given you optional to optional. Please download the latest version, because the diagram also had an issue. I fixed them. So you can see here, I fixed them by using, in case if you have downloaded it earlier, I fixed them yesterday and uploaded it back by fixing mandatory to optional diagrams. Okay. So the first one here, we have mandatory to mandatory. We are saying that one citizen must have a passport. There is no way that one citizen will not have a passport. It must for him to have a passport. But obviously it's their choice whether they will apply for it or not. There is also chances that they will not have it. But as per the rule that we should have a passport, right? Then each passport should belong to one citizen. There is no way that we have a passport and it is not belong to someone else. Okay, I'm here now. First, we are saying that one citizen must have a passport, because there is no way they will not have a passport, because they need to have an identity. But obviously there are the chances that some people, they will not pay for the passport and get the passport, but we know that they should have. Then for passportless citizen, we are saying that one passport should belong to one citizen, because we cannot have an empty passport which is not belong to anyone. So that's why both ends are mandatory. Now the second one, which is mandatory to optional. Mandatory to optional, I have given you example for the staff and office. It's the same one I have given you for the optional. It's just 2 scenarios. Both of them are 2 entities, same entities. Okay, let's look at the mandatory to optional. So every employee has a designated office. So we are saying that every staff have been assigned an office, but there are chances that some of the offices do not have any staff. because they haven't been assigned to anyone. Okay, so that's why this side, which for the office, is mandatory and the staff is optional. As I have said that we always we read from left to right first, but we put on the right entity. So mandatory is here and optional is here. Now the third one, which is optional to optional. Same example. We are saying that some employees who are working remotely, it's not necessary they will be assigned any office. It's not necessary. There are a number of employees who do not have an office because they work remotely or they are on contract basis. They just come, for example, for the faculty itself. Not all faculty have an office. Some of them, they just come for the class and they leave. Okay, so this is one example for you. So that's why it is optional. When we look at office to the staff, some offices will be vacant and it can be served as a meeting room, or it can be a shared spaces. So it becomes like it can be optional as well. Okay, any questions here before I move to the next relationship? Okay, so I'll move to the next one as no one have asked me any questions. So now here we have one-to-many relationship. In one-to-many, I also have given you different scenarios here. The first one is mandatory to mandatory. We are saying that we have two entities here, which is university and the student. We are saying that one university should have one student. Is it possible that there is no student in the university? Which is not possible. If it's a university, there should be one student at least. Okay, one university will have many students. It cannot have only one student. So we know the relationship here is one-to-many. When we read from student to a university, each student must be affiliated with one university. There is no way a student who is called as a student or a person who called as a student is not affiliated with any university. Okay, so they should be affiliated with a university. So that's why both ends are mandatory here. Why it is one-to-many? Because one university should have one or more than one students. So that's why it's one-to-many. Now for mandatory to optional. Mandatory to optional, we have two entities here, library and book. Each library should have one library or each library should have a book. Is there a possibility that library doesn't have any books? Which is not possible, which means it should be mandatory. Obviously, if it's new library where we haven't bring any books yet, then we can say that. But as per logically it is correct that library should have a book. There is no library which doesn't have any books. Okay. Then we have book to library. So book to library, not every book necessarily belong to a library. What does it mean? It means that whenever we are seeing the book, that book is belong to you, which is you have bought it, you haven't bought it from the library, or it is in the bookstores. It's not necessary that those books belongs to the library. So that's why we have an optional here. Okay. Again, I will repeat, one library should have one book or one library should have multiple books. But one book which you own, for example, not necessarily it is belong to a library. You are the one who bought it, you paid for it, whether it's from the bookstore, whether it's from maybe from someone else. Okay, so these are the two examples you have to consider. Now for the optional to optional. For optional to optional, we are saying that we have author and the book. When we read from the author of the book, we are saying that not all author will write a books. Why? Why it is optional? Anyone can tell me? Why do you think that it's not necessary for an author to write a book? Anyone have a guesses? Any idea why do you think that author will not write a book? If someone will not answer, I will call your name. Yes? Yes, you are right, Rafael. You are right, Eduardo. Danica, you are also right. Okay, so the author will become author when he will publish something. Okay, or that author may be author of some other type of, or other type of publication. It cannot be only books. Here we are only specifically saying the books. Okay, so that's why it's optional here. In this case, it is optional. So when it can be author of a magazine, maybe a conference papers and so on. Okay, so it's not necessary that all author will be an author of the books. That's why it's optional. So when we read from the book and author, it is also optional, because there are some possibility that some of the book doesn't have any name for the author. It is anonymous. It is rare case, but here we are thinking of the rare case here that there is no name of the author. Sometimes it's missing, sometimes they haven't printed. The ones which is illegally published or published on that site, it doesn't need to have an author names. Sometimes the author want to be anonymous. Sometimes they use a fake names. So there are some possibilities I have. You always have to think about the scenario as well. So whenever I give you a scenario, you always have to look at the scenario and then you will answer based on it. Okay. In case if I haven't given you anything, given in the scenario, then you can make an assumptions there. Any questions here before I move ahead with the many-to-many relationship? Okay, so now we move to many-to-many relationship. We already have discussed the many-to-many relationship earlier. But here I have given you one example, student and courses. We are saying that one student will enroll in one course. One student will enroll in many courses. This is from left to right. Then right to left, we are saying that one course will have one student, or one course will have multiple students. So what will be the final answer will be many-to-many. So whenever we have many-to-many relationship, which means we have to introduce a new entity. We have to create a new entity here. So we have introduced an entity called as enroll here, enrollment. The relationship here is mandatory. Why it is mandatory here? Any one of you, why do you think it's mandatory here? Why one student must be enrolled in one course? And why one course should have one student, let's say? Okay, so whenever we have a course, we cannot have a course without a student, right? Yes, if he didn't enroll, he's not a student. Okay, yes, he is not a student and you have to be enrolled to attend. Yes, so whenever we have a course, the course should have a student. There is no possibility that we are delivering any course and there is no student in the class. So we must have one student in a course. That's why it's mandatory. The same for student to the course. If he's a student, he must enroll in a course. So if he's not enrolling in the course, which means he's not a student. Or he can be categorized into two other types. The students who are alumni, or the ones who are currently active. We can say that current students. In that manner, we can say that if they can be optional or it can be mandatory. If it's alumni, obviously it is optional because it's not necessary for them to be enrolled, in the course because they already have passed out, they already have graduated. If they are current student, it becomes mandatory. Okay, is it clear now? Again, we are categorizing into current student. I'm sorry for my writing. I will try to make it clear now. Current student or alumni. Alumni is the one who graduated already. Now I will move to the next type, which is mandatory to option. So we have faculty and course, and we are saying that it's every course must have at least one course. Okay, sorry, I have read it wrong. Go ahead. I think I have to fix this slide as well. So here we are saying that not every faculty need to be assigned to a course because maybe that faculty is part-timer or working on the contract. So which means maybe that specific faculty will not teach next semester. That's why it should be optional. Okay, it should be optional here. And if we read from the course to the faculty itself, every course must have one faculty. There is no way we are teaching one course and there is no faculties assigned to it. So that's why here we have a must. The description is correct, only I have to change the symbols here. Okay, so I already have changed it here. Any questions here? I think so I have changed it, but I think so maybe you can check on Learning Hub, you may find it there also. I will check again because yesterday I have discussed it and then I have changed it, but maybe I have missed this slide. Okay. Any questions here? The only example I can give you when faculty is on leave, maybe it is a part-time or contract based. So it's not necessary that he or she will come in the next semester or teach you. Okay. So this is only example you have between faculty and the course. But in case if faculty is a full-timer, he must teach a course. Okay. But in Canada, I do know that some of the faculties, they can take a leave for one semester. It can be related to research work. It can be for anything. In Canada, it's a little bit different. So again, you have to think about where exactly you are. But I do know in Canadian universities, we do give a break for one semester to complete maybe any course, maybe complete or their research, or maybe in publication they're working on, they can take a gap in between as a full-time employee as well. Okay. So now the next part, which is many-to-many relationship. So in many-to-many relationship, both of them are optional. We are saying that one employee may or may not be assigned to a specific project. Why do you think if there is a project in the project a company is working on will not be assigned to any employee? Again, I will repeat. Why do you think that employee may or may not be assigned to any project the company is working on? Any one of you? You can also unmute yourself and can speak because sometimes writing takes time. Okay. Okay. Yeah, a little bit close, but the mainly is because sometimes the company, they outsource their project. Mostly the IT companies, they do it. They do have an employee, but in order to work on specific project they are working on, they outsource from outside. They are not employee of their company. but they work as an outsource employees, okay, as a freelancers. So in that case, it becomes optional, which is mainly related to freelancing or freelancers. We call them as the freelancers mainly. Now we are saying project to employ. One project may have one employee or may not have any employee assigned to it. That's why it becomes optional to optional, because here we are thinking that as an IT company, majority of the organizations, they outsource. They hire a freelancer for a certain time, but they are not their employees. Okay, they are not there on their payroll. Any questions here before we move ahead? Because I will move to generalization and specialization now. Okay. So we have relationship degrees. We have seen the binary relationship already. We have seen the ternary relationship. We have three relationship, which is somehow similar to associative entity, because we are saying that there are many-to-many relationship between two entities. So we create another entity. We call it as a conceptual relationship or ternary relationship. We do have ternary relationship where we have four entities out there. What does it mean? So if we are thinking there is a doctor who will prescribe a patient a drug, we can create another entity out of the prescribe, which is called as a prescription. Then we will have a logical diagram, okay? Which means we think this is a relationship between them and we create it as an entity itself, okay? So these are the relationship, but which one I want you to focus here is a unary relationship, which is self-referencing entity, okay? We call it as self-referencing as well, which means we have one entity and it has a relationship with itself. How it is possible? So we are saying the employee who is also a manager manages one employee or many employees, which means still he is an employee, but he have a different title or position as an employee. So which means we have a self-referencing of an entity. We also call as unary relationship. Okay. Any questions here for self-referencing or for unary relationship or any other degrees? Okay, so I will move ahead with that. So we have how to read an ER diagram. I have given you an example. We always read from left to right, but we always add a mandatory and optional on another entity to the next entity where we are directing towards. So you can see here, based on above the diagram, an office has 0 or 1 faculty working on it, so which means it is optional. Then we have a member of faculty works in one and only one office, which means one and only office, which means it is mandatory. Now we have third one, faculty 2 the semester. We are saying that a member of the faculty team teaches 0 or n semester. N means many semesters, so it is optional. A semester is taught by 0 or n faculty, which means it will be optional as well. Okay, this is something we already have done. Only this slide is for you to understand how to read it. I already have explained to you earlier. It is a repetition of it. Now let's look at this example. You have to draw an occurrence diagram, entity relationship diagram. I'm giving you 5 minutes to try to attempt this one, and then I will solve it for you. If you have any questions, you can write on the chat. I'm giving you 5 minutes. After 5 minutes, we can continue on it. I will explain to you how to create an ER diagram. Okay, so now the question here says occurrence diagram and entity relationship, but I will draw for you entity relationship diagram because it's something related to your week 4 exercise, which can solve it after this question. How to solve it? You will always divide each part into separate. Now let's read the first one. We are saying there are 2 sentences are here. So we will dissect it into 2 parts. Now let's read the first one. A car may be driven by many drivers during the week or by none. So now we will look at, we are saying the entity is a singular noun, or it can be plural, because plural means in the sentence it will be plural, but we will draw or write it as a singular. Again, we read it, a car may be driven by, so car is an object, which means it will be our entity 1. It says maybe, which means it will be optional. Driven by, which means it has a relationship. By many drivers. So if we look at the drivers, it seems like it is also an entity because it is also an object or person or thing. These all are an entity. So how we can draw it here? It will be car. And here we will be having a driver. You have to, we don't have enough time to draw on visual right now. So that's why I'm drawing here. And I want to show you the scenario. Else you have to draw it on visual, okay? So now we are saying a car. It says car only, which means we have only one car. May be driven. So it says maybe. Driven by many drivers. So we are saying it will be a many drivers here. This is our first part. Any questions here before I move to the second part? So we are saying that one car is driven by many drivers, and we are saying maybe, so it means it is optional. We do not know right now from driver to car whether it's optional or is it mandatory yet. Okay, for that we have to proceed with our scenario. I will read the second part now, which is a driver may drive many cars and always drive at least one. It says a driver, so we are referring to a driver here. May, so it means it can be optional. Many cars, which means one driver drives many cars, and it says here it is maybe. But when we proceed further, you can see here, and always drives at least one car. Okay, again, I will read, a driver may drive many cars. One driver may or maybe drive many cars. And then we are saying that, and always drive at least one. So again, we are referring to only one driver in this sentence. And we are saying that at least, which means it is mandatory, and one, at least one. Okay, so one driver, he can drive many cars, or he can at least drive one car. So the relationship here, this one was for car to driver. Now this one is from driver to car. Okay, so the relationship here, the one will become one, but we already have many here, so we do not have to change anything because we already have added from car to driver. Here we have one to many, which will be many. Whenever we have to decide between maybe to at least, we will always go for at least, which means it is mandatory. So now we will change our relation here from one to many and put it as a mandatory. So our relationship will look like something like this. Whenever we have many to many, we have to create an associative entity, but this scenario doesn't say to have another entity. Okay, so mostly whenever we have many to many, we create another entity, but in this case, it doesn't say anything, so we are not creating any entity here. Any questions? This is how you have to solve your exercise number 1. It's only one exercise is there. You have to solve the scenario. It's not that long. Any questions? Okay, so I will move ahead with generalization. We do not have enough time. So I will move with the extended entity relationship model. So whenever we are saying the extended entity relationship model, we are referring to ERM, which means we have additional features or additional notations in that specific diagram. And when do we use it? Whenever we have inheritance. What is inheritance is mostly used in Java or object-oriented. Okay, so what does it mean? We have different terminologies we use for that. We use specialization. We use specialization, generalization, or inheritance. It means same thing. But in ER, we call it as extended ERM. Okay, what does it mean? It means we have one entity. From that entity, we derive multiple entities. Okay, what does it mean? We are saying that we have one entity such as employee. From that entity, we derive a new entity such as full-time employee, or part-time employee. So from one entity, we have derived two more entities. This entity is called as parent entity or parent class. It is also called as super entity or superclass. It is also called as super type. It is also called as base entity. It's same terminology we use for parent entity. So whenever we have derived two entities from the parent entity, we call them as, both of them will be called as, if it's called as a parent, it will be called as a child entity. It will be called as, if it's super, it will be called as a subentity. If it is super type, it will be called as a subtype. If it is base entity, it will be called as a derived entity. Okay. So how do we represent this in your diagram? We use this symbol in order to represent that. You will use that in inheritance in mostly in object-oriented or Java. Why do we use it? Because we are saying that we want to make sure that we are reusing or because of reusability. We are reusing the properties, which is mainly a reusability. What does it mean? It means that we are saying that we have an entity such as the employee, which consists of employee number, employee name, and employee hire date. These all properties can be inherited to its child classes. Okay. Whereas they can also have their own new attributes as well. So it will inherit all the it will inherit all the properties which is belong to an employee, which will be inherited to full-time employee and the temporary employees. But they will also have their own attributes as well. We use a symbol, as you can see it here. It is same example in your real life. For example, your parents own a property, right? So you will inherit some of the properties from your parents, but again, you also buy your own properties as well. So the sum of the property you will have, which will be inherited from your parents, and you will also own your own properties, which you have purchased yourself as a child. So this is how the inheritance works, that you will inherit all the properties or all the characteristics or all the attributes from your parent class, which will be used in the child class. Okay, so how do you have to draw in the visual? I will quickly show you the notations we have to use, because we have only 4 minutes left for our meeting. So this is your lab 4. what you have to do, you have to include the 2 more entities here. You have to name as institutional and private customer. Sorry, I have included the classes here, sorry. So from the Crawford, you have to include 2 entities more. Once you have done that, you also have to use inheritance. Inheritance is not there, so you move to the more shapes, software and database, and from database, sorry, software and database, software, you will include a UML classes. These all steps are given in your labs as well. Then from here, you will be using association to create a link between them. You'll be using inheritance in order to link it with the main entity. So main entity here will be a customer. And you will link them through the association link. This is how you can draw the visual diagram. Just a minute. So this is how you can include the inheritance in Microsoft Visio. And in your lab 4, you also have something called as a legend. So for the legend, I can show you how you can work on it, but I want to first show you the lab itself, because it's the same diagram you are using from your lab 3. You do not have to create from scratch. So same thing will be using what you have done in the lab 3. The only difference here is that you have to include a legend and you have to include the subtype, which is 2 more entities. Okay. So what is legend, I will explain to you in a while. But before that, you can see here all the steps are given, which means you only have to give me 2 more entities. How the output should look like, I will show you now. Your output should look like something like this. Hopefully you can see there, this is a part which you have done in your lab 3. You are just including 2 more entities, which is institutional customer and the private customer, which are the subtypes. Okay. This is for lab 4. And now you have to include a legend. How you can include a legend? What exactly the legends are? The legends are the ones which consist of number of notations you have used in your diagram. So it will consist of entity you have used, the entities you have used, the attributes you have used, primary keys we have used, foreign keys you have used, and all the type of relationship you have used. So for example, how you can create a legend, you go to the insert container. So you can see here, you have to name it as a legend. You can expand your legends. You can expand as you want to based on your relationships. First, we have used entity. So you drag and drop the notation from here to here. So I will put them back because it's giving me the wrong entity here. So you can just export the entity here and you can say entity with attributes, no need to include all the attributes there or attribute notation there, because this one already consists of the attributes. Then for the primary key or foreign keys, you can include the attribute here and just right click on it and set it as a primary key. So you can call it as a primary key. If you have multiple relation, for example, here you have one to many and it is optional, you have to mention all the links. If you have inheritance, you just draw this one here and you can say, you can call it as inheritance as well. So in case if you want to make sure you want to move all the symbols together, you use control and click on all the links you want to connect together. Go to menu, right click on it. You will see here something called as a group. It will group all the elements together and you will be able to move them easily. Okay, for me it doesn't because I haven't click on the third link. Okay. Now for the relationship, we have said that we will be including it here as well. So you can change, because you can see here we have 1, 2, and we have inheritance. So all the symbols need to be included, what you have used here. I haven't included the foreign keys, but you have to include all of them. If it is bold, you have to mention that it is not null. So these are the legends which are used mostly in the ERD diagram. So whatever diagram you create, I want you to create a legends, because you will have a marks for the legends. Okay, so whenever you draw ERD diagram, I want you to have a legends. Is it clear? Any questions now? So what you have to submit for your lab 4, you have to submit this entire diagram, which consists of a legend and 2 subtype. How to submit it? There are 2 files you have to submit this time. You have to submit your video file, and you have to explain the subtype and supertype. Okay, is it clear? And for you have to put in the folder and zip the file. That's it. Any questions before we end our today's session? Okay, there is something called as a disjoint and non-disjoint. Okay, I will quickly just give you overview of it, and then we'll be done. Just a minute. We have something called as a joint and disjoint. We do know about the mandatory and optional. These are a disjoint constant. We call a non-disjoint as an overlapping as well, and we use a symbol and. So whenever we have 2 entities or 3 entities which are linked to its parent class, we always look at whether it should have a common attributes or not. So whenever we have a common attributes between both of them, the parent and the child, we will say it is non-disjoint, which is overlapping. If we do not have any common attributes between a superclass and the parent class, we will call it as a disjoint. So non-disjoint is common attributes, and disjoint is not common attributes. Okay, I can write it for you here as well. It's given in the slides, but still I can write in as a keyword for you. So we are saying that non-disjoint, we call them as overlapping as well, which is common attributes between parent and child. And disjoint is not common attributes. Okay, so that's it for today. You can try to attempt your week 4 exercises, and I will let you know about our next session or online session, which will be an extra session next week. Okay, because I still have to figure out if we have any extra sessions or on Wednesday or Friday. I still have to confirm them based on the room's availability, because majority of you have mentioned that you want it to be face-to-face. So I'm not sure if any room is available or not. Any question, please let me know. We're done for today.